So now let us see on how we can be able to solve the natural log equations. So by this far we already know how to solve the actually equations that involves log. That is how you should get it. In case you missed that, just have to ensure that you came across that in my actually a video playlist. You come across this, and also I may think of having the link in the comment section below. So make sure that you have followed that. You should have to understand that there are two forms of the logarithmic functions. We have what you call y is equal to log, let's say, b of x, and we have y is equal to natural log of x. So these are the actual forms of the logarithmic functions. So now in this video we can go over on how we can be able to solve actually equations that involves the natural log. So I want you to be part of this and be able to understand what is it about. So now these are the things that you should have to know about the natural log actually aspects. You should have to understand that the properties of the log are the same even for the natural log. So the properties of the log are the same even for the natural log functions. So you should know that. And also you should know that the ln of, let's say, 1 is equal to 0, and the ln of a is given as well. You should know this. The ln of 0 should be the ln of 1 is given as 0, and the ln a, it is given as, and that should be 1. And also you should have to understand that, let's say we have, let's just have to state it up. Let's try to solve the following. Let's say we have the ln, let's say x is equal to 5. So what is the solution corresponding to this equation? So now we are to solve for x, and which is a part of the natural log. So at the end of the day, we should have to remove actually the natural log. Now the process of removing the natural log is said to be the actually aligning. We call it as the align, where we are removing the actually a natural log. So how should we be able to remove the natural log in order to solve for x? So now the natural log is removed upon introducing a, and of which a 5 has to be the power of a. In this case we'll have it as x is equal to a to the power 5. So whenever we are removing the ln here, and in the same case we introduce e, that would be in which this one will be the power of that one. And let's say we have another case. Let me think about it. Let's say we have ln, let's say x is equal to, let's say, 5, should be 8 rather. In this case we should have to solve for x, which is part of the ln. So in this case we should have to delete this, and in the sense that we have x is equal to, then we have e to the power 8. And let's say we have a ln, let's say 2x. So in this case the principle remains the same, and we should have to delete this. Let's say we have ln of 2x is equal to, let's say, 1. So in this case we should have to delete this, and in the same case we'll have it as 2x, and is equal to e to the power 1, and which is the same as 2x is equal to e, and have x is equal to e over 2. Of course the value of e is fixed. The value of e is fixed, which is given as 2.70 like that, but we do not really need to have the exact value of, actually we do not really need to have the value of e, just have to indicate the value, actually just have to use e instead of having, actually instead of interpreting that one. In much as we we are not allowed to make use of, actually we are not allowed to use calculator. But in case you are allowed to use the calculator, then you may think of having the value of a, which is 2.70, and divide by 2, you have the answer in, that should be in a decimal form, can be about 2 or 3 decimal places, based on the nature of the question or the nature of the solution. So now let's say we have ln, let's say x plus 5, and that is equal to, let's say, 6. So how should we be able to solve for this? So you can see that we are looking for the x, and which is the part of the natural log, hence we should have to delete this. In that case, we'll have x plus 5 is equal to e to the power 6. Hence we'll have it as x is equal to e to the power 6 and minus 5. So this is the solution. Now how about if we may have this? Let's say we have a ln of, let's say, ln x, let's say is equal to, there should be -4. So what will be the solution of this problem? So now we can see that we have the ln x, which is also under the outer ln, which is ln. So we should have to delete the first ln, in the sense that we have ln x, and which is equal to e to the power -4. And we should also have to delete the other ln, where we have x is equal to e to the power -4. So this is the solution. You should have to get that and up to. And how about, let's say if we have this, let's say we have the ln of ln, let's say ln x. Let's say this is the case, and is equal to, let's say, 5. What is the solution of this actual equation? So now the first thing is to delete the outer ln. In this case, we'll have it as ln, and that should be ln x is equal to e to the power 5. Then we should have to delete the other ln, hence we'll have it as ln x is equal to e to the power 5. That should be e to the power 5. Then we should have to delete the other ln, we'll have it as x is equal to e to the power 5. So this is the solution you should have to get it up to. And let's think of having this case. Let's say we have a 5 to the power x is equal to, let's say, a 3 to the power 2x minus 1. So now what is the solution of the x in this case? How should we be able to solve for x? So now we have the exponential equations, and in this case this is the base 5 and this is the base 3, and in other words the bases are different. Now there is no possible we can have to express 5 to have the lowest base other than 5 itself, and we cannot also be able to express 3 to have the base other than the 3 itself. So in this case we are going to introduce the natural log both sides, so which means we'll have ln 5 to the power x, and which is equal to ln 3 to the power 2x minus 1. Then according to the properties of the logarithms, we'll have x ln 5, and which is equal to 2x minus 1 in the terms ln 3. Then we should have to expand this. We'll have ln should be x ln 5, and which is equal to 2x, and ln 3, and minus ln 3. Then those with x's inside, we'll have them together. We'll have x ln 5 minus 2x, and that should be length 3, which is equal to length 3 in this case. Then I'll think of factoring out x, and that will be given as x, and which is equal to negative length 3 divided by, and that should be length 5 minus 2 length 3. So that is the solution of that. But if you are alright to make use of the calculator, to use calculate, then I'll just have to punch these values, then that will be the solution. This one can be about 2 decimal place, all 3 based on the nature of the problem. But you are advised to have it in 2 decimal places or 3. It is a pretty fine to have that. But in case the calculator is not allowed, and based on the course that you are dealing with, or the nature of the course itself, then I just have it in that way. And let's say we have 7 to the power, let's say negative 4x, and which is equal to 2 to the power 1 plus, let's say 3x. So in this case, you are going to introduce ln both sides. That will be given as ln 7 to the power negative 4, and which is equal to ln 2 to the power 1 plus 3x. In this case, we'll have it as negative 4x, and ln of 7, which is equal to 1 plus 3x, and that is times ln 2. Now we'll have to distribute ln 2, that will be given as ln 2 and plus 3x of times ln 2. Then we'll have it as negative 4x ln 7 minus 3x ln 2, and is equal to ln of 2. So try to finish off that. Try to finish off that at your own time. Now let's say we also have this. Let's say we have e to the power 2x, and let's say plus e now should be plus 2, and e to the power x, that should be plus 1, which is equal to 0. So now, how can you be able to play around with this? And of course, using the laws of indices, we can be able to manipulate this in the sense that we can be able to have e to the power x and the times e to the power 2. And that should be e to the power x times to the power 2, and the plus 2 e to the power x, and plus 1. To make sure that whatever you have here, it is the same as whatever you have here, so that we can be able to use the we can be able to express it as a quadratic equation. So now let's say e to the power x, and that should be equal to m. Hence we have m squared plus 2m and plus 1, which is equal to 0. Then we use the factor method to solve for m. Hence we have m squared plus m and plus m plus 1, which is equal to 0. Now in this case we'll have m now should be m plus 1, and we'll have m plus 1, and which is equal to 0. So make sure that you have the skills of how to factorize the quadratic equations. In this case we'll have it as m plus 1, and also have m plus 1, that is equal to 0. Hence we'll have m is equal to negative 1. And also in the same case we also have m is equal to 1 as well. In other words, this is actually a perfect square because we are having the one little root. So we are having the one little root, that is m is equal to negative 1. So now since we actually had this, then we'll come back to this. We'll have it as e to the power x is equal to negative 1. Now as it stands here, we'll have to, now in this case we'll have to introduce lin both sides, in the sense that we'll have, should be lin e to the power x, and also in this case we'll have it as this. We'll have it as ln of -1, and of which the ln of -1 does not exist, hence the actual equation has no real solution. So the actual equation has no real solution because the ln of negative number, it is given as, it does not exist. And I also try to think about this one as well. Let's say have e to the power 2x, and let's say minus 2 e to the power x, and say minus 3 is equal to 0. So we can also use the same as well. In this case we'll have e to the power x, and that to the power 2 minus 2 e to the power x minus 3, that which is equal to 0. So in this case, let e to the power x, and that should be equal to m. So in this case we'll have m to the power 2 minus 2m minus 3, that is equal to 0. So in this case we'll have it as m squared, and that should be plus, should be x, should be m rather, and that should be m minus 3m minus 3, that will be equal to 0. Then we'll have it in the sense that we should have it as m and the m plus, and that should be a 1 minus 3, that m plus 1, that which is equal to 0. In this case we'll have m plus 1 in the times m minus 3, that is given as 0. Hence we have m is equal to -1, and m is equal to, should be a 3, and of which automatically this one want to give us the little solution. Hence we'll use the other one. In this case we know that e to the power x is equal to m. Now we'll have to substitute. We'll have e to the power x is equal to 3. Introducing ln both sides, because this is also exponential equation as well. We'll have ln e to the power x, which is equal to ln 3. In this case we'll have it as x, ln a, which is equal to ln 3. Then this is 1. In that case we'll have x is equal to the ln 3. So by the way, you have to understand that the ln 3 is a constant number. It's a constant number, hence that's the solution. So keep that in mind about this. And now let's say we have this case. We have e to the power x, and minus e to the power -x, the which is equal to 1. So in this case we'd like to solve for x. How should we be able to solve for x if this is the case? So now using the laws of indices, having this case, you should have to understand that this is the same as e to the power x minus 1 over, this should be e to the power x, and which is equal to 1. So we should have to multiply everything by e to the power x. In this case this is the same as e to the power x, and e to the power x times e to the power x minus e to the power x, and which is equal to e to the power x. So we'll have, no, should be, we'll have here minus 1. So we'll have here as -1. Now since the bases are the same, we'll add the powers. Hence we'll have e to the power 2x minus 1 is equal to e to the power x. So think of having this together. We have it as e to the power 2x minus e to the power x, and that should be minus 1 is equal to 0. You know what it means here. So try to have that at your own space. I just need the responses in the comment section, how tough or easy it is. Now how about if this is the case? Let's say you have a to the power 3x and is equal to, should be 10 to the power, let's say 2x, and times, let's say 2 to the power, let's say 1 minus x. Now how should you have the solution of this? Now in this case we cannot be able to express 10 to have the base of 2. Otherwise we cannot express 2 to have the base of 10. In this case we use the same principle of introducing the ln both sides. We'll have ln a to the power 3x, and which is equal to ln of whatever we have 10 to the power 2x, and times 2 to the power 1 minus x, and of which, using the laws of logarithms, we'll have 3x, which is now should be 3x ln a, which is equal to, now we are multiplying a here, it is the same as adding, so we have ln 10 to the power 2x and plus ln 2 and to the power 1 minus x. So in this case this is the same as 3x, and this is 1, and is equal to 2x ln 10 and plus 1 minus x, and that should be ln 2. Then I will factor, actually we'll expand this and distribute ln 2, then you'll be able to have the value of x in that case. And also we should have it in the same way as it is there. Now let's think of having this case. How about if we may have this? So you can finish that one on your own. Let's say you have ln x and plus, let's say, ln of, that is what, x plus 1, and is equal to, let's say, ln 12. So now how should you have the solution of this? And of course we have a ln x, and also we have here, in other words, we have ln with x here, and also we have the ln with x here. So using the laws of logarithms, so what will happen is that we'll have, now this is the same as having it as ln, now should be x, the ln x now should be ln x, and the times x plus 1, and which is equal to ln 2, should be ln 12. Of course this is a constant, then we should have to delete this in the sense that we'll have it as x times x plus 1, which is equal to e to the power ln 12. Then in this case we'll have it as, now we should have it as x squared and plus x, which is equal to e to the power ln 12. So now in this case this is the same as having it as x squared and plus x minus e to the power ln 12 is equal to 0. Now you should have to remember the way the computing square method of solving the quadratic equation is being used. And for instance, we have the quadratic equation x squared plus bx and the plus c is equal to 0. You will see that having solved for x as the subject formula, we use the computing square method, where we end up having x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2. So we're going to use the same principle. In other words, you are going to use the same principle of the way the quadratic formula is derived. in the same case, you also be able to make x as the subject in the same way we actually have that. So it will be like that. And for instance, you may think of having this one to be whatever a letter can be given as x squared and plus x minus, let's say, m is equal to 0, where you end up making x as the subject formula. So in this case, that would be that. Now you'll be able to have, let's say, the value of x using the completing square method that you should know, deriving from this and up to this. How should you have the same with let's say you should have here actually this 2a here, so you should have to make x as the subject formula there. That would be the solution. So I understand you know how to derive the equation, quadratic equation, from that of the actually you know how to derive the quadratic formula from the quadratic equation. In other words, you know how to solve the equations using the completing square method. It is the same principle, you should know. By that, you'll be able to get it. Actually, you'll be able to get that. You'll be able to get the value of x. So now, let's say we have this case. We have a ring of x cubed, and should be this. Is equal to, let's say we have 3 ring x. So now, how should you be able to solve for this? Now try to have this at your own time. So you should try to recall whatever we've been doing, if it is possible to. Let's say we have ring x to the power, let's say 3, and which is equal to, let's say, 3 ring x. What would be what would be the solutions for this? So now let us see how we can be able to solve the logarithmic equations, and that involves inequalities. So now this part of the lesson, or this part of the video, requires you to recall about solving the linear inequalities and also the polynomial inequalities, because you'll be actually required to complete the solution set on your own, much as you are much aware about the solving linear inequalities and also the polynomial inequalities. That involves the use of the testing table. So in case you forget about how to solve the polynomial inequalities, you just have to go through my video playlist. You come across that one and you watch that, then you'll be able to complete that at your own time. That is very important. Let's say we have this case, and that should be, let's say we have 4 in the times 10 minus e to the power, let's say, x, and that should be less than or equal to -3. So what is the solution for this? So now first thing, we'll have to divide both sides by 4. So in that case we'll have 10 minus a to the power x, which is less than or equal to -3, and over 4. Then we'll have to transfer 10 to the other side. We'll have it as -a to the power x less than or equal to -3, and that should be over 4 minus 10. Then we may think of having this as the single fraction, of course. Then having that, then we divide both sides by negative, and that will be given as, -1 divided by -1, and of which this is the same as e to the power x less than, now should be greater than or equal to, because we are dividing negative number both sides. that is the same as 3 over 4 and plus 10. So you think of having this as the single fraction, hence we'll have to introduce ln both sides. That will be given as ln e to the power x greater than or equal to ln whatever we have upon having this as the single fraction, and we'll have x and ln e and greater than or equal to whatever we have here. Then this is 1. That will be the solution on whatever, on the ln of whatever we have here upon having that as the single fraction. So in this case, so let me just have it. But you need to be well mastermind about actual fractions. So in this case, we'll have 4 here as the common denominator. We'll have 40 plus, we'll have 3. So which means we have 43 over 4. So ln 43 over 4. So have ln 43 over 4. So which means we have x greater than or equal to now ln 43 over 4. So this is part of the linear inequality. So this is the solution. Now, how about if we have this? Let's say we have this kind of a case. Let's say we have it as this. Let's say e to the power 2 plus, let's say x greater than or equal to 100. So how should we be able to solve for x in this case? Now we're going to introduce ln both sides. We'll have it as ln e to the power 2 plus x greater than or equal to, we'll have ln 100. Then we have it as 2 plus x, and that should be that times ln e greater than or equal to ln 100. Of which this is the one, we'll have it as 2 plus x greater than or equal to ln 100. So this is part of the linear inequality, where we'll just have to transfer 2 to the other side, and I'll have it as x greater than or equal to ln 100 minus 2. That is the solution. And let's say we have this case. Let's say we have, that should be, let's say we have it as 2 to the power x, let's say greater than 0. Let's say greater than 0. So now, how should we have the solution for this? So now, you should have to understand that in this case, we'll have to introduce ln both sides. We'll have ln 2 to the power x greater than, let's say, ln 0 in that way. And of course, let's think of using the laws of, let's think of using the laws of logarithms. So having 0, now I should have it in this way. We'll have 2 to the power x greater than, now in this case we'll have it as ln 1, because ln 1 is the same as 0. Then we'll have to introduce both sides the ln. We'll have ln 2 to the power x now should be greater than ln of ln 1. Now in this case we'll have it as, now should be x times ln 2, which is greater than ln of ln 1. So in this case we'll have x greater than, should be ln of ln 1, and that divided by ln 2. So that is the solution. And of course, on the other hand, you may think that the solution actually you may think that the equation has no real solution, because at the end of the day we should have to get it that the ln of 1 is the same as 0. But if you tend to apply the laws of the laws of logarithms at some extent, this will be the solution. So there can be two ways you may think about it, but I just have to get that one up to. And maybe you may think of using, let's say, chat AI or whichever the source to verify, but that is the level based I can provide you with for now. There may be two ways: whether the equation has no real solution, or either the equation we just have to apply the laws of logarithms at that extent, from the fact that having having linear from the fact that having 0 it is the same as ln 1. So whichever the way, but just have to be flexible on how to use the laws of logarithms. That is the base of it. Now let's say we have this case. Now think about this. Let's say we have e to the power, let's say, x squared, and let's say we have minus 4x, and should be greater than or equal to 8 to the power 5. So how can we have the solution for this? Now since the bases are the same, then we just have to equate the powers. So in this case we'll have it as x squared minus 4x greater than or equal to 5, and of which this is the same as x squared minus 4x minus 5 greater than or equal to 0. Now this is part of the polynomial inequality, so try to have that on. Let's say we have, in this case, let's say we have e to the power should be 1 over x minus 1, and that should be greater than 1. So in this case we're going to introduce ln both sides, in the sense that we'll have ln a to the power 1 over x minus 1 and the greater than ln actually 1, and of which this is the same as 1 over x minus 1 the times ln a greater than, that should be, what is the ln 1? It is given as 0, and of which this is also 1. We'll have it as 1 over x minus 1 greater than actually 0. Then we'll think of having this as the single fraction, hence we'll have it as, we'll have x here, and I'll have, we'll have here negative actually x, and we'll have it as 1 minus x. We'll have 1 minus x over x greater than actually 0. This is a rational equation that will be required to solve using the testing table, the way we solve the polynomial inequalities. You can remember that you go for the testing table and have everything there, so you should have to make sure that you are much aware about all those things, and at your own time try to go through for this. Let's say we have a 5 to the power x minus 2, that should be greater than, let's say, 4. Let's say we have ln of, let's say, 3x minus 4 divided by 4x plus 1, let's say less than or equal to ln 4. And let's say we have 10 to the power negative x squared, and less than or equal to 10 to the power negative 12. And let's say we have a to the power, let's say 1 over x minus 1, and that should be greater than 1. And also try to go through this and appreciate that. Let's say we have 3 log of 10, and that should be 4x plus 3 less than 1. And also try to go through for this as well, where we have, let's say, a 2 over 3 and the 1 minus e to the power, let's say, negative x less than or equal to negative 3. And how about this? We have, let's say, log 2, let's say, of x greater than or equal to 0. But you should have to understand or remember about the laws of the laws of logarithm. That expresses that having here as 0, it is the same as having it as log 2 1. So having 0 is the same as that, so which means you unlock both sides, and where you have x greater than or equal to 1. Think about that. And we also have, let's say, you should have to also try this as well. Let's say we have log of 2 and 2x minus 1 over, let's say, x minus 1 should be lather x minus 2 and less than 0. And of which, in the same way, you should know that having 0, it is the same as having it as log of 2 of 1. You should know that we have one of the properties of the logarithms, that is log b of 1, it is the same as, should be 0. So we are using that actually property. In case you are not much aware about that, just have to go through the video we discussed about properties of logarithms. You come across that, and let's say we have log 2 of x plus, let's say, log 2 of x plus 1 in the minus log 2 of, let's say, 2x plus 6, and that should be less than 0. And also use the same principle, because whenever we are solving for logs, we need to have everything in terms of log. So we use that principle in that case. And also try this. Let's say we have ln x and plus, let's say, ln x plus, let's say, 2, and less than or equal to ln 35. So what is the solution for that? You'll be able to have that one as well. And you should also be able to understand about how we can be able to have this. Let's say we have this case. Let's say we have, now let me just have to give you the further practice questions you may need at some point or the other. Let's say we have, alpha. Let's say we have alpha actually ln of x plus, let's say, ln beta is equal to 0. Mind you, upon just have this, this is the same as ln m, and also this is the same as whichever the later we think about. So try to solve for x there. And also, what if we have, let's say, log, let's say, of 6x, and which is equal to 1 divided by, let's say, 1 over log 6 of x, and plus 1 over, let's say, log 6 of 2x. So try to have the solution for x there. And also think about this one as well. Let's say we have now should be let's say half 7 to the power log of 7, and that should be 2x, that which is equal to 2x. So now what is the solution for this? So try to go through for that. And also, what if we have this? Let's say have log 2, let's say log 2x minus, let's say log 2x minus 2, and greater than 0. Now try to go through for this as well. So that's how you have to understand about the solving equations that involves the natural log. Actually, thank you.